Yeah, previously we saw narrowband FM, waveform and generation. Now we are going to see about wideband FM. So wideband FM, it has the features that it has an infinite number of bandwidths. So narrowband FM, it has only one, it consists of three bands only, but it has that wideband FM has infinite number of bandwidths. And in narrowband FM, the modulation index is less. That means it's less than one. But this wideband FM modulation index uh, is large. That means higher than one. Then so it consists. The spectrum consists of the carrier. Uh, the spectrum has a carrier and infinite number of sidebands. In previous narrowband FM, the spectrum consists only carrier and lower band and upper band. Here, infinite number of sidebands are appeared in wideband FM. And you know that wideband FM, it is used for broadcasting applications like FM, TV, radio. That narrowband FM is mainly used for wireless, that police, ambulance, taxi. So they were used in narrowband FM. But if wideband FM, that is a commercial application, they used for broadcasting, FM, radio, and TV. So wideband FM, it's infinite number of bandwidth and modulation index is large. It's more than one, and then spectrum consists of carrier signal and infinite number of sidebands. Also, it's used for entertaining purpose, broadcasting, such as FM and TV. So Spectra and Modulation Index. Transmitted baseband signal XM of t is equal to sinusoidal carrier waveform XC of is equal to AC cos 2 by FCT. This is nothing but carrier signal. So FC is a carrier based frequency. So the AC, the amplitude and that combined to baseband data. So the transmitted signal they consider as a Y of t, that AC cos 2 pi integral 0 of t f tau d tau, then AC cos 2 pi integral fc plus f del xm tau divided by d tau. So AC cos 2 pi fct plus 2 pi f del integral of 0 to 2 xm tau d tau. Modulation index. So modulation index it's indicate how much modulation varied. Based on the modulation index only is divided into narrowband and wideband. So if the modulation index is less than one, that is we can call as a narrowband signal. Then if the modulation index is above one, that means large modulation index, then that is we can call as a wideband signal. So, in the variation of carrier frequency, the modulation index equation is h of del of FM. So, where FM, you know that high frequency of component. So, f del hm of t divided by FM. So, the maximum deviation of instantaneous frequency of the carrier frequency, that is, the del is a deviation of frequency. So, that's the instantaneous frequency from the carrier frequency. So, that's the thing. I think we already seen in narrowband FM modulation index already we saw from narrowband FM. So it's a little bit give information about modulation index. So similarly, I already said the modulation index is less than one. That is we can call as a narrowband FM. If maximum means more than one, that is we can call as a wideband FM. So that is the thing you shown in see here. Example, they put it as a hatch here. Hatch is if it is less than one, the value of hatch of is equal to zero point 0.3. Pi is by below zero point 0.3. The value is narrowband FM. So H is equal to del F divided by FM. This is the equation seen from last slide. So again they shown in the FC plus del F or FC minus del F. So depending upon the binary state zeros or one, the modulated signal will be varying. So I said previously it is less than one. It is now the H value is more than one. So if it is more than one, it's a wideband FM. So this is shown in the bandwidth signal. Uh, okay, then it can be improve the signal noise ratio significantly. For example, if the doubling the value of delta f while we keeping the constant, so the signal noise ratio also it will be improved. Okay. Okay, then power relation and transmission bandwidth. Um here, that sideband, we see that bandwidth of the FM signal. So first one is n is equal to number of sidebands. No, the center one is carrier frequency. In between there are two sidebands. You know how many numbers of sidebands? Only one sideband is present here, and then second represented as a sideband. Two sidebands are present here, and third one is represented as a four sidebands, and fifth one represented five sidebands. So only few sidebands are contain major share of the power, 98% of total power. So it considers a significant sideband. That the Carson rule, the 98% of signal power are in FM. That bandwidth is equal to the deviation frequency plus modulation also doubled. The Carson frequency bandwidth, see the equation 2 del f plus fm. So del f is nothing but twice the deviation frequency, also modulation frequency. So that's a thing they shown in the diagram, power relation of transmission bandwidth. Okay, okay, thank you.